Okay, this session I'm working on SimpleArchiver. At this point, this feature I'm adding is kind of, it's just a nice thing to have. It's not necessary. Long story short, when you're testing the archive, let's say a tar file, maybe you want to know if there are just if there's a main directory inside of it and then files inside of that. That use case inspires this new feature, which is getting the maximum amount of, as the argument implemented in parser, you basically set a depth number, like a depth number, and that number determines how many slashes a file name or a symlink or a directory is allowed to have before printing it at most. So if you set this depth to 0, you'll only get names that don't have slashes in them, allowing you to see if an archive is composed of a single directory holding stuff, or more if you want to set the depth to 1. That's basically the feature. And it only works in test mode, not archive mode, not extract mode, only test mode. As that's the basic use for this new feature. So here I'm trying to find a good place to put the argument parsing for that feature. A flag which is --text or test-max-depth. And naturally, as most other options in this program can handle, you can use an equal sign or without one, and without the equal sign, it expects the number after some white space. Some typos. I guess, yeah. Some typos. I'm pretty sure I fixed this typo eventually. So right now the maximum depth is set as the default, which is basically the maximum number of a 32-bit unsigned integer, which is about 4 billion. And I know this because everybody knows that 32-bit systems can only have 4 gigabytes of RAM max, because 32-bit systems uses 32-bit pointers. Those 4 bytes can only address up to 4 gigabytes of memory. So whenever you see a 32-bit unsigned integer, you should know, oh, the maximum value is approximately a little over 4 billion. And so by default, the depth is set to this maximum value. As by default, testing an archive should print all the contents information. Setting a depth to 0 would let you know if there's like a single directory holding everything, but yada yada yada. Yeah, that's basically how that one is. This part of the code, I'm trying to just ensure that if a 0 is returned from parsing the number, that it actually is a 0 as a C string. Because the conversion can return a 0 if there's invalid text. So if I just did, if I just set the word, if I set a word instead of a number, like the word text or something, I don't know, that would return 0 for this string to unsigned long function. And well, with the setup like this, I need to ensure that if 0 is passed, 0 is actually the string that is set. Long story short, I'm just validating the input to make sure that the 0 is actually the user inputting a 0. So as you can see, I typed in 8 F characters after a 0 and an X. In C and C++ and Rust, is I'm pretty sure, and probably Python, a 0 and an X and then characters after that is a hexadecimal literal number. So 0x0 to 0x9 is just 0 to 9. 0xa is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. And since hexadecimal refers to 16 possible values, which is 0 to 15, a single digit in hexadecimal ranges from 0 to 15. And 16 would just be 0x10, which is the carryover, because the 16 is not F, it is 10. F is 15. And so 1 digit of hexadecimal is about 4 bits because up 0 to 15 can be represented with 3 bits. Or 4 bits, sorry. Not 3 bits. 3 bits is base 64, I think. Is it? No, that's 6 bits. Base 64 is 6 bits. Hexadecimal is 4 bits. Anyways, yeah. 2 hexadecimal decimal digits is basically 1 byte, long story short. Here I'm making sure the parsing works. So at the start of editing archiver.c, I know that I have an argument. I know I have a new unsigned integer to use to reference to, so that when I output information, I should ensure that in test mode it should respect this value. But as usual, with a large code base, it takes a while to get used to the same thing over and again. If you have a lot of code to work on, and you haven't worked on it for a while, well, there's only 2 things that can happen. You remember or you forget. And if you've forgotten, you reread it until you get it again. And that's kind of unfortunate, because I make some mistakes at first, a little bit inefficient checking of this value against the file name, symlink name, directory name. So these first edits in archiver.c, I think most of it gets changed eventually by the end of the session. That's just the nature of it. Planning probably would have helped somewhat beforehand, but you still have to dive into the code to get a feel for what has to be put in there. And well, this working on SimpleArchiver, I'm just working for myself. I'm not working for a company when I work on this. This is my own personal project. I don't go by anyone else's rules. If I was working in a company, we'd have like agile, stand-up meetings every morning, figuring out what to do every day, planning it out so that we can coordinate and get things done. But when I'm working for myself, I'd rather just dive straight into the code, which is messy, but I just prefer to do that when I work by myself. So I'm pretty sure that some people may take offense to how I program on my projects. But if you don't like it, well, that's too bad. That's just what I do when I'm by myself. If you want the program to be something else, you can fork it and make your own version of it. It's open source. Other than that, that's just how I work when I'm by myself. Planning would have been something like, oh, let's find all the places where things are output and then add a check. And I'm actually doing that. I'm finding places where outputs are made and I'm adding a check. But I realize I have to do it a little bit differently, and I'll mention that when it happens in this session. Note that this voiceover is a recording made long after, well, a day or two after the recording has been made, or the video recording has been made. The cast asciinema recording has been made, like, I'm getting it backwards. The voiceover has been made after the recording of the thing by at least a day, because this session happened to be 2 hours long, and there was a lot of preparation to do. The cast file was so large, I can't even pass it to the asciinema player, because apparently it's larger than the maximum size of a string allowed in JavaScript in the browser, in both Firefox and Chromium. So, on my website, I instead have a video player and an MP4. The video player being a built-in video tag, and the browser provides the video player. I do have like little buttons to seek in the video where markers should be. So there's no asciinema for this. Like, I did record it with asciinema into a cast file, but there's no asciinema player playback for this on my website for that reason. 2 hours, it just happened to be so long that the cast file is too large. So for some reason, the first thing I decide to have this new option taken effect on are symlinks in every file format while it's being parsed. Yeah, there isn't really a particular requirement to do that first. I just decided to work on symlinks names first. It isn't that big of a deal compared to the other. Like, there are 3 things being printed in general when you test an archive: directories, symlinks, and files. And it's trivial to get the name of each thing. It's not trivial to find every instance of prints for everything that is printed. It takes a while. This session is basically busy work. Basically, finding all the places where prints are made and doing a check to make sure that it prints only when it's supposed to. I changed the function to use a 32-bit unsigned integer instead of a 16-bit unsigned integer. Some warnings about conversions and or settings, variables, something like that. It probably makes more sense to use 32-bit integers, because under the hood, a 64-bit system probably uses 64-bit integers more often than 32-bit integers. And if you're using a 16-bit integer, well, that might be stored in a, what's it called, a register on the CPU that can hold 32 bits or 64 bits. I'm not entirely certain if a 64-bit machine only has 64-bit registers, but I do know that if I have a 16-bit integer It probably is better to use a 32-bit integer instead to make use of the full size of the register available to the CPU. And this holds true for 32-bit systems because a 16-bit integer would be put into a 32-bit register in the CPU, that kind of thing. So might as well use at least 32 bits, not 16 bits for an integer. And here I realized I forgot to put in the help text the information about the new argument I added for this new feature. So I put it in the help text now. Like I said, it's kind of busy work, but I have to find all these instances of printing information and check against the 32-bit integer I set up for this. Note that this option only takes effect when I'm testing the archive, not creating it. The do extract flag is true when extracting, and that is not testing, that is extracting. Actually, why did I mention create first? This function only gets called on test and extract, and do extract is true on extraction. So, yeah. If that's false, then the new integer I created holds for every print of a file or symlink or directory. So the Boolean logic here is basically either print this when do extract is true. If it's false, then print it if it is allowed by this new integer I set up. The OR logical OR can be used in this way such that it ensures that what follows it is the expression is evaluated after if the before expression is false. So sometimes you might see a bash script that does or true, or vertical line true, or something like that. That's to ensure that the call of that line always returns true. Because every command that you run in the terminal has a exit value. Like if you look at a C program, you notice that the main function returns an integer. That's it. That integer you returned from the main function, that's the value that is returned from into the terminal when you run a program. If you're in Bash, you could run a program and then you could do echo $? And that prints the exit value of the previously run command. Some scripts are designed to fail if a command ever returns non-zero, which is an error value. And so I forgot why I was saying this. Oh, that's right, a logical OR. Bash commands that end with OR and then true are designed such that that line will result in the exit value being 0 or success. The true command does this. To break it down, it's like expression or true. The expression in the front doesn't matter if it returns error or not, because the or true at the end ensures that if the first expression is false, the second expression is right, and that value is that return value from the second expression is the return value of that statement. So long story short, or true makes the line never return false or error. Basically, kind of rambled on there. Sorry about that. So in Vim, you can save arbitrary text into arbitrary registers. That's what they're called in Vim. There's a special register for the clipboard, and there are registers, which is every letter of the alphabet on your keyboard. If you save to the clipboard register, you can paste it somewhere else. If you save it to a letter register, you can refer it later with a command on Vim and paste that register. I think the Q and then the letter saves your input into a register for later use as a macro, but I disabled the Q macro recording command on my Vim. I don't really use macros in Vim that much, if ever. I don't know, it's weird. I think I realized here that all of my symlinks are within a subdirectory, meaning that they only print if the option is set at value 1 or greater. So I make a symlink in the build debug directory so that it would show up even if the number was set to 0. So note that I'm testing the symlink output, not the file or dir output, because I've only implemented it for the symlinks. Symbolic links. So using this option for file format 0 is probably the easiest part of this, because it treats files and symlinks kind of similarly in the way that it's archived. Note that file format 0 is inefficient because it doesn't store files in chunks. It stores files one by one, such that if compression is used, each file is compressed separately. File format version 1 and onward combine chunks of files together and compresses those chunks at the same time. Well, long story short, it just combines the contents of files and then compresses that huge chunk together per chunk for the entire archive. This is the point where I realize, oh, I should have used a boolean flag like object, variable, or bit flag to store the information that whether or not the current file or symlink or directory is allowed to be printed by the rules of the args, which is if in test mode, print the name if the name has up to this many slashes in it. And there's stretches of code here that are for a single item. So it makes sense to cache the result, kind of caching. Well, it makes sense to get the result of that check first and then use that result later on as the printing happens. It's done a little bit differently for different sections of code, but the main thing is a single boolean or a single bit is checking for whether or not the name should be printed in test mode. The shortcut thing in C is if a value is 0, it's considered false, and if a value is non-zero, it's considered true. This is how pointers are checked actually, because null pointers can't be dereferenced. Any null pointer that shows up is considered to be either set to null on purpose to say that, oh, it hasn't been allocated yet, or by error. So a null pointer by itself in an if statement is false because null is 0. and any non-zero value is true, which would indicate that a pointer, if it was non-zero, the if statement check would be true. And so it goes on that it doesn't just apply to pointer types, it also applies to integer types in C. In the if statement, if an integer type is 0, it's considered false, and every non-zero value is considered true. And I'm pretty sure this also holds for negative values. So at this point, after figuring stuff out for file format 0, I'm going back to file format 4567. This particular function is called when parsing those file formats. They combine functionality because the file formats are similar enough for this to, well, it's just how I implemented as I added file formats as time went on. New features are simply gated by the version number, so it still works fine for me. As you can see here, the usage of a cache variable boolean makes it easier to check. Instead of having to do the check completely from scratch every time, cache it for when the name is received and then do based on that boolean. Sometimes I have like this bug with LSP, language server protocol, so I restart NeoVim. I am using NeoVim in this session because the plugin for language server protocol doesn't really work with regular old Vim. LSP, by the way, does code completion in the way that you type a function name and it tells you the names that match that name you're typing. That's basically all LSP can do. It can also help with folds in Vim, but I decided to use folds based on syntax that Vim can understand instead of LSP folding. Long story short, LSP remembers the definitions of struct members, class members, function names, variable names, and by remembering these names for you, you can autocomplete these names by hitting tab usually. And you can't do much else with LSP. It's not vibe coding because it's not AI. It's some kind of code parsing thing. That's why it doesn't work sometimes. Like, if you have a syntax error in your code, LSP may fail to do name completion for you. So I'm pretty sure that makes sense for in different contexts as well. But long story short, LSP is just name remembering. Helps you navigate your code base by allowing you to not have to fully remember the exact name of a function or a variable, or a member variable, or a class name, or a struct name. But you can't really use it if you don't know the first letter of the name you're looking for. So it doesn't completely replace looking at documentation. If you don't know how something works, you have to look it up. If you need to remember the name of an API, but only remember like the first word of it, LSP is really helpful for that. I think I made a mistake here. I didn't compile before running the program. But I'm not entirely sure what I was thinking, because it's been a day at least. A day or two. One day, actually. So the structure of my code in this part, parsing file formats 4, 5, 6, and 7, I should note that the file format is basically has all this file metadata for every file, and then it parses the chunk that has those files. Which is why it's separated here. I use an internal file info struct to keep track of each file within a chunk, because in the file format, like I said, it's streaming in the file format, and since it starts with file metadata and then the chunk that may or may not be compressed, I store information about every file from the metadata, and then I act upon the chunk with the file metadata received at the time of receiving it in this program execution. So I add another bit to be reserved for use for the new feature I'm adding in this session. Instead of using a sentinel boolean kind of thing, because I'm reiterating through the file list again when only after all the files have been parsed, the file metadata, when the chunk is being extracted or tested, the files are iterated through, and it should be in the same order as files in the chunk by design. And so that is when the check on the file name takes effect by setting it not a Boolean variable, but a bit in a variable that is designated for bit flags. Bit flag being like a Boolean within an integer, since technically every number in a program is a series of bits. So a number, a variable, like a 32-bit integer, that's basically 32 bits. You can use it as 32 booleans, or you can use it as a number by itself. That's just the nature of computers. Everything is a number, especially by base 2 number, which is 0 or 1. A single bit is 0 and 1. Or 0 or 1, sorry. So there's a mistake here. If you can catch it, I'll explain it as I fix it. It's kind of hard to check, actually. If you're not familiar with my code, I should probably explain it right now. The permissions from bits version 1 function, the second variable passed to it is used as a boolean. And that tells it if to print to standard error the information if it is true. So the error was that I didn't set the value based on whether or not the new feature should allow it to print. Here, directory names are directly handled after they're given in the file format. So I can use a boolean value here, or boolean variable. Note, I don't use a bool keyword, because technically C doesn't have a bool keyword. It's provided by a header, actually. And I figure I'll just use a variable that's just a uint fastDate t. The fast is within that keyword indicates that it's guaranteed to have enough data for 8 bits for an 8-bit unsigned integer. But it's fast as in it's something like, well, long story short, the compiler and the assembly handles it in such a way that it may be faster to handle it because it might actually be a 32-bit integer instead of an 8-bit integer. Something like that. I remember looking up the documentation for uint fast8 or int fast8, fast16, faster2, all that. It's basically that a fast8 integer is guaranteed to be at least 8 bits large, and it may be larger. For the sake of speed, not speed, for the sake of this word that's on the tip of my tongue that I don't remember right now for some reason, compilers compile code such that it's more efficient in certain ways based on what it knows from the code, like constant guarantees. Like if the variable is constant, it knows it's never going to change, so it can make a optimization. Okay, yeah, so the fast keyword basically means it's optimized for speed when it's compiled. I don't remember the exact word I was looking for, but that's basically what it does. Basically, it might be 8 bits, it might be larger, it won't be less, otherwise it won't work. It's guaranteed to be at least that number of bits. And this is the result of that thing I was talking about. Not passing to the permissions function whether or not that file is allowed to print information based on the new feature I added, which is print if the number of slashes is less than the number, less than or equal to. Since the variable is being used as a boolean kind of thing, the thing I said earlier applies. It's non-zero, so if it's non-zero, it's true. If it's 0, it's false. And that bit is set if it's allowed to print. The ampersand by itself, followed by a number, is a bitwise AND operation. Technically arithmetic. Basically, AND 8 means take the variable, that integer, use bitwise AND on the following value with it, and return the result of that AND. If you had the number 3 and you AND it with 2, you would get 2 from that, because 3 is the first 2-bit set and 2 is the second bit set. And like an AND gate in logic for electricity or whatever, or Boolean logic, the 3 and 2 is 2, and 3 and 1 is 1, and 3 and 4 is 0. It's a bitwise operation. Bitwise arithmetic. That's how I'm able to handle bit flags Okay, this is what I'm talking about LSP not working if syntax is bad. I specified the const keyword, I specified the type as a uint fast-at, but I didn't put a variable name, and then I put an equal sign after. And that confused me because I didn't realize the mistake, and LSP stopped working for me. And there ended up being some formatting issue that apparently I missed when I set up a hash map with string-based keys. This should have been fixed by the previous work, but apparently this one line is over 80 characters long. So I had to carefully stage my changes in Git so that I would make this a separate commit to fix this. So I've now confirmed that the new feature works with file formats 4, 5, 6, and 7, as they share the same function. So I'm going down from there. Now I'm going to work on the parsing of file format version 3. So my previous code setting up this for symlinks did not cache the value of whether or not it's allowed to print. So there are some instances where I actually replace a check with the variable I set for this. Again, maybe it would have been caught in planning, but then again, you'd have to dive into code first to know in the first place, I would think. You may disagree with me. Well, that's just how it is, I guess. We may both disagree. Again, when handling files, I have a file info struct set apart for handling the metadata. And like I said before, the file format, the file metadata is separate from the file data itself stored in the chunk. I forgot to mention, LSP also provides some syntax coloring, syntax highlighting that is. And whenever syntax highlighting doesn't work, I try to reset LSP And then for some reason it resets my fold, so I have to unfold the code again before losing my place. Thinking about it, it's very fiddly in a way, I guess, but most of the time it works, so I put up with it anyway. So this is something you might be able to check. It's not a bug, but it's an efficiency thing. I think I'm deliberating on whether or not to add the check here. There's a flag that gets set that basically tells it whether or not to print this error again. I think I might have handled it wrong at one point, but I'm not quite sure if I fixed it later. I'll probably look it over again soon. Sadly, this is a one-man operation, so So this is what I was talking about earlier of something you might be able to catch. Instead of doing a separate check against individual bits in the other flags variable, I can combine the checks. So previously it was ampersand 6, and 6 is 4 and 2, which is the second and third bit in the 8-bit value. And I set the fourth bit as the bit to print with the new feature. So 6 is the second and third, and the new feature uses the fourth. 0, 1, 1, 1. That's 0xe. All I have to do is ampersand bitwise and with 0xe or 15 or 14. Sorry, that's 14. F is 15, E is 14. And it's basically 8, 4, and 2. And by checking if it has these bits together, I can check multiple booleans at the same time. And realizing this, I go back in the code where other places I could do this optimization. Oh, that's the word I was looking for. The word that was on the tip of my tongue was optimization. Maybe. I think. Optimizing for speed? I think I said that already. Never mind. Anyways. Yeah, so this optimization allows for... Well... I'm not exactly sure how it looks in assembly, because when any code is compiled to a binary file format, it's literally instructions for an x86-64 processor or instructions for an AArch64 processor. And assembly is a representation of that binary format. Long story short, I'm not sure if the compiler optimized for doing these bits together, but I would assume it has. The compiler does a lot of heavy lifting for the programmer thinking about it. Yeah, I think I reloaded LSP and it refolded all the folds because I reloaded LSP because I thought the syntax highlighting wasn't working properly or something. Very fiddly sometimes. Looking back, I can see that I could have optimized the checks on all these flags as well. But I guess that's a change, refactoring for another time. So this is basically almost non-stop, about 2 hours session. I guess I got a little loopy when I indented that line wrong. I should really take breaks more often. I mean, I have the cast recording set up such that it doesn't allow for a pause longer than 3 seconds. So I could technically just leave my desk and get a break, and the cast would only pass 3 seconds per change on the terminal. But I don't know. Yeah. I'm not really good about taking breaks on my own. Something that I should think about more. So at this point, the implementation on file format 3 is just about done. I just need to test it, that's all. And then I move on to 2 and 1. So the parse function for file format 2 is interesting because it actually calls the file format 1 parse function, because the file format version 2 appends to the file format version 1 implementation. So I'm able to do this at the time. Meaning if I want to fix version 2, I also have to fix file format version 1 at the same time to make sure that they both have the same behavior as expected. So I work on both. And now that I finished the parsing version 2 function, I go straight to the version 1 as mentioned earlier, that the function parsing version 2 also calls version 1 function. So to get the fix to work in version 2, I also have to fix also have to get it to work in version 1. Or the parser for file format version 1. The parsing. The function that does the parsing. I don't know. It's a bit pedantic, but some things you have to say exactly. Again, this is fixing the initial pass of implementing this for symlinks. I worked on symlinks first, and I'm switching the literal check into the cached check result. Long story short. Again, using bitwise operations to set the flag. There is an operator that is just a single vertical line. That's a bitwise OR. There are some operators that is an operation with an equals after it. And that basically is a syntactic sugar for apply the following to the current variable. So in other words, apply the OR, the bitwise OR that follows this equals, and apply it to the variable on the left. So that's the implementation of the new feature for file formats 1 and 2. What's left is testing, and that should be that after testing, that should be it for this session. So at this point, it's basically done. I do step into code a few times to do some efficiency with bit flags and stuff like that, I think. But other than that, that should be the end of this session. So that's basically it. There's probably like 11 minutes, 10 minutes left, I don't know. Thanks for watching.